This is section 8.1, ratios and proportions. A ratio is a comparison of two quantities. I've given you three different ways to write ratios. A proportion is a statement that two ratios are equal, usually written as one fraction is equal to another. You could also write it as one ratio is equal to another, as in number 1. Probably the most important property of a proportion is what's called the cross product property. It says if A over B is equal to C over D, then AD, the cross product here, is equal to BC, the cross product here. Because this is a geometry course, I do want to give a quick proof for why that is true. I have A over B is equal to C over D, and let's say I want to have a common denominator. I think I'm going to multiply both of these terms by BD. The multiplication property of equality says I can multiply both sides of an equality by the same scalar and I will end up with the same number. So if I do, I'm going to get on the top, I'm going to get A BD over B is equal to CBD over D. On the left-hand side, the B's will cancel out. On the right-hand side, the D's will cancel out. And sure enough, I'm left with AD is equal to CB. And the symmetric property says that's the same thing as AD is equal to BC. You can always cross-multiply to get an answer when you're using proportions. The second property of proportions is if A over B is equal to C over D, then B over A is equal to D over C. Notice we're just flipping the fractions. I don't think that would be very hard to show, and I think if I may just ask you to prove that later on, but it's true that if A over B is C over D, then B over A is D over C. The third one, if A over B is equal to C over D, then A over C is equal to B over D. Maybe I will prove this one pretty quickly. Remember, by the cross product property, I know that if A over B is C over D, then AD is equal to BC. Now I can divide both of these terms by CD, so I'm going to divide this term by CD and this term by CD. I guess this is only true if neither of those terms are equal to 0. Now I can cancel out a D on the left-hand side, I can cancel out a C on the right-hand side. On the left-hand side I have A over C, and on the right-hand side I have B over D. All of these are true only when the letters do not stand for 0. Division by 0 is still a problem with any of these properties. All right, number 4, if A over B is equal to C over D, then A plus B over B is equal to C plus D over D. Why is that true? Well, once again, by the cross product property, I have AD is equal to BC, and by the addition property of equality I can add the same thing to both sides, so that's going to tell me that AD plus BD, I chose BD and you'll see why as it comes out, is equal to BC plus BD. Well, not only can I add both of these quantities, the same quantity both sides of an equal sign, but I can also divide through by the same quantity as long as I'm not dividing through by 0. So I'm going to divide through by BD. If I divide through by BD on this side, I need to also divide through by BD on this side. Okay, on the left-hand side of my equation, I'm going to factor out a D, and I get D times A plus B over BD is equal to, on the left-hand side I'm going to factor out a B times C plus D over BD. Now on the left-hand side, I can cancel out the D's, and on the right-hand side, I can cancel out the B's, and sure enough, I'm left with A plus B over B is equal to C plus D over D. I have some problems for you. I'm not even going to do examples. I think you've done enough of these to be able to solve the problems on your own. So why don't you pause the video and see if you can solve the first problem. Okay, the cross product property says I can multiply across these two. So 8 times x must be equal to 4 times 6. 8x therefore must be equal to 24. Dividing through by 8, x must be equal to 3. And so I get 3/4 is equal to 6/8. X is equal to 3. Number 2 is like number 1, except that we're going to have to remember to FOIL, or use the distributive property. Please don't try to do this without foiling out your x plus 4 times your x plus 8. Pause the video and try it now. Here we go, using the cross product property, x plus 4 times x plus 8 is equal to 3 times 4. So x squared plus 8x plus 4x plus 32 is equal to 12. So x squared plus 12x plus 32 is equal to 12. This is a quadratic. It has a squared term in it. So I want to put all the terms on the left-hand side. The right-hand side will be equal to 0 and see if it's factorable. I'm going to subtract 12 from both sides. And I'm going to get x squared plus 12x plus 20 is equal to 0. I need two numbers that multiply together to give me 20 and add together to give me 12. Hopefully you'll see those are 10 and 2. 10 and 2 are my magic numbers. So x plus 10 times x plus 2 is equal to 0. If a product is equal to 0, one or the other factor has to be equal to 0. So x plus 10 equals 0, meaning x equals negative 10. Or x plus 2 equals 0, telling me x is equal to negative 2. If I plug in a negative 10, negative 10 plus 4 is negative 6. Negative 6 divided by 3 is negative 2. Let me write that on the side where you see it. If I plug in a negative 10, I get a negative 2. If I plug in a negative 10 over here, I get 4 over negative 2, which is also negative 2. So negative 10 is one of my solutions. Let's see what happens if I plug in a negative 2. If I plug in a negative 2, negative 2 plus 4 is 2, and I get 2/3. If I plug in a 2 on the other side, I get, I get 4/6, which is 2/3. 2/3 is equal to 2/3, so x equals negative 2 is another possible solution. My solutions are x equals negative 10 or x equals negative 2. Problem number 3. A room is built from a scale drawing that is 1 inch by 3 feet. The scale drawing is 3 feet by 5 feet. What are the dimensions of the room in square feet? Well, I know that 1 inch to 3 feet is going to be the same scale for my width as 3 inches to x feet. Cross multiplying, I get x is equal to 9. So my width must be 9 feet. On the length, I get 1 inch to 3 feet is the same as 5 inches to x feet. This time x is equal to 15, so I have a 9 by 15 feet room that was scaled down to 3 inches by 5 inches. Okay, I hope this does it for you. We'll do some more problems in practice, or some more practice problems in class. See you there.